So, we will continue the Miller indices of planes. So, in last class I have discussed the how to find out the Miller indices for a crystal plane. So, this HKL is basically Miller indices, putting in a first bracket represent the crystal planes. So, this Miller indices its value it's basically integer value. So, for cubic crystal from just faces of the unit cell, there we have seen 3 planes 1 0 0 0 1 0 and 0 0 1 0 0 1, right. So, 3 planes we have seen. Now, when I showed this one 1 0 0, so that basically that plane intersect the a axis, intersect at a axis, right, at 1a or 2a, 3a, 4a. So, it can intersect also this other side, other direction, negative direction of a axis. So, minus 1a, minus 2a, minus 3a. Okay. So, to differentiate it, whether it is intersect at plus side or minus side. So, we write this one not minus 1, but 1 bar. So, 1 bar it represents that it intersects at the negative side. So, this can be planes, this can be planes 1 bar 0 0 0 1 bar 0 0 0 1 bar. Okay. So, this here just I want to say that if it intersect at negative side, negative direction of the axis, so that information we include in the Miller indices, taking the bar on the indices. Okay. So, this so let us see some planes other than this simple plane 1 0 0 0 1 0 etc. So, I think here I can show you this some planes. So, you see, as I showed, there is just these planes are 1 0 0. If this is a axis, this is b axis, and this is c axis. So, this plane intersects only the a axis, right. So, it is 1 0 0 plane, it intersect. So, how to find out already you know. So, it intersects say 1a, then b and c axis it intersect at infinity. So, 1 by 1, 1 by infinity, 1 by infinity. So, that will give you 1 0 0. Now, if there is a plane which intersect at the middle of this, say at a by 2, if it is intersect at a by 2. So, this figure, you see this figure. So, this is 2 0 0, how it is coming? So, it intersect actually half A, infinity B, infinity C, right. So, we have to take the reciprocal of this 1 by half, 1 by infinity, 1 by infinity, right. So, that is basically 2, 0, 0. Okay. So, this will be the plane, and here that is why we have shown 2 0 0 plane. This is the 2 0 0 planes. So, I think here this D 2 0 0 is not 1 0 0. The interplanar distance D 1 0 0. So, this is the Miller indices. Generally interplanar distance we write dH KL. Okay. So, H KL plane, the interplanar distance is dH KL. So, here it will be D 2 0 0. So, this plane is 1 1 0 plane, 1 1 0 plane. So, that also easily you can find out, because this is the A axis. So, this plane intersect at 1 A, and this is B axis. So, this plane intersect at 1 B, because this is the unit cell. So, it is so this distance between these two corner lattice point here. So, this will be A, this will be B, and this other one C axis. So, this plane is didn't cut or intersect at C. So, it is parallel, this plane is parallel to C. So, it intersect at infinity. So, for that one 1 0 1 1 0 plane. So, what is that? It is intersect at 1 A, 1 B, and infinity C. So, take reciprocal of this, simplify it. So, it will be 1 1 0. Okay. So, this is 1 1 0 planes. So, this, as I told, is 1 bar. So, this is the so this is the A axis, this is the B axis. No, I think this we have shown so, if I consider this one, just it is rotated this one. Okay. So, axis is, one axis is this, another is this, and another is this. So, this is A axis. So, say this is B axis, and this is C axis. Okay. So, this is, so in this case, okay, it's, we are telling 1 bar 0 0. So, as if this, it intersects at the negative side of this A axis. So, that is why it is we are telling, as I mentioned already. So, A bar. Okay. So, this represents, so this way we represents the different planes of the crystal, and one can find out the Miller indices of these planes. Okay. So, this so let me go back to the unit crystal, unit cell for cubic crystal. In cell of cubic crystal, Okay. So, this one thing is clear that how we are getting HKL. So, wherever intercept, so this H basically coming from the reciprocal of that one. Okay. So, from HKL value, if I want to find out the intersection of the planes with the axis, so then how to find out? Right. So, if it is HKL plane, so where it intercepts on the axis, so this, so we can write this, it intercepts at a axis at distance a by h, right. It, because h is basically from here you can see, so it was half a, intersects as half a, but to get the h we have taken the reciprocal and simplified it. Okay. Now, from h, if we want to get the intercept, so again we have to take reciprocal of this h, 1 by h times a. Okay. So, thus this it intersects at a axis at a by h, b axis b by k, and c axis l by c by l. So, this HKL plane, it intersects at axis a axis, b axis, c axis where at a by h, b by k, and c by l distance from the origin. So, that is what here it is shown here. So, this is the plane, this is the one plane, this is the HKL plane, this is the HKL plane. If it is HKL plane, so it intersects at a axis, the a by h, that at b axis at b by k. So, this is the distance intersecting at this length, and along the c axis this is c by l. Okay. So, that is what I explained here. Okay. So, if I know the plane, then I can get the intersecting length on the axis, and these are from here for these planes say, okay, if I take this the origin, this is the origin. So, this plane intersect at, so if I tell this is the 1 0 0 plane, okay, 1 0 0 plane. So, where it will intersect? Where it will intersect on the axis? It will intersect on the axis a by h, means a by 1, b by k is 0, c by l, c is 0, this l is 0, so c by l. So, here you are getting just a by 1 a, 1 by 0 infinity b, 1 by 0 infinity c, right. So, this 1 0 0 plane intersects at a, infinity b, infinity c. Okay. So, this intersecting length on the axis is verified with our crystal planes, which we found from the procedure of Miller indices. So, this plane, when we find out the Miller indices, at that time we consider that it intersect at A, infinity B, infinity C. Okay. From there we found the Miller indices. Now, from Miller indices itself we can find out the intersecting point, intersecting length, and that is the same. So, this way we can get the intersecting points on the axis from the Miller indices of the planes, and this I need to calculate basically the interplanar distance. So, H-scale plane is not a one plane, it is a one set of parallel planes. So, it represents a one set of parallel planes. Okay. So, suppose this H scale, this is a plane, H scale plane. So, let me draw it. I am considering slightly different axis system. So, this is A, this is B, this is C. So, this is a plane, this is a plane. So, this H scale plane, this is a H scale plane, this is H scale plane. Okay. So, that means it intersects. So, this length will be, so this is the origin. So, this length will be A by H, this length, this is B by K, B by K, and this is C by L. Okay. Now, I want to find out the interplanar distance. So, as I mentioned that this is H scale plane, but it represents a set of parallel planes, equidistance interplanar distance will be same between two planes. Okay. So, this interplanar distance for this plane H scale plane we represent by, as I told, DHKL, right. So, this DHKL is the interplanar distance. Okay. So, a set of H scale planes, a set of planes, parallel planes, which is basically H scale plane. Now, what is the interplanar distance of H scale planes? So, that we want to find out. Okay. So, here we can consider that this through origin there is a this H scale, this parallel planes are there, and this again this other side, the back side. Okay. So, lot of parallel planes. So, one planes passing through the axis, passing through the origin of the axis parallel to this, So, interplanar distance, then I can consider that if I take normal on this plane from the origin. So, this if I take normal, I think I should take slightly off, then it will be. So, say this point. So, this is the normal on this plane from the origin. Origin is O and this is N, normal on these planes. Okay. So this ON, so this ON will be basically DHKL, as I told that this a parallel plane of this HKL plane on parallel plane passing through this origin. So, then normal from the origin on this plane is basically then this ON is perpendicular distance between two parallel planes. So, that DHKL and then what we find out? We want to find out the DHKL value. So, this is DHKL, right. So, you have plane and this is the normal, ON is the normal on these planes, right. So, if this normal have angle with A axis, B axis and C axis, say phi 1, phi 2, phi 3, or let me write phi A, phi B, phi C. Okay. So, these are the angles of this normal with the crystal axis. So, then this angle, so this ON having angle phi A with the A axis, so I think basically this angle, right, and with the B, this have angle, this one phi B, and with C, this is the angle, we see this is the angle, so that is phi C. Okay. So if we take the, so this the, so if I consider this one, so it's a better easier one. Okay. So this dotted line on the plane, this dotted line on these planes, and this one is normal to this plane. So this angle is basically 90 degree, right? This angle is 90 degree. This angle is 90 degree. So if it is 90 degree, so here you can see this cos phi b, because this angle is phi b. So cos phi b will be equal to this by this DHKL, or I can write ON, this ON by O says we can give name B, intersector A and this intersector C. So ON by OB, right. So ON is basically your DHKL divided by OB is B by K, right. So cos phi b is equal to this. So this I can write k by b DHKL, DHKL, right. Similarly, you can find out cos phi b, phi a will be equal to, this is h. So, h by a DHKL and cos phi c will be L by C DHKL, right. So, here basically this cos phi A, cos phi B, cos phi C, these are the cosine directions of this normal. So, it follows cosine rules, so that cos square phi A plus cos square phi B plus cos square phi C equal to what? Direction cosine rules. Okay. So, just if you put value of phi A, cos phi B, cos phi C. So, h you are getting h by A square DHKL. So, I will take this outside DHKL. So, the square. So, because it is everywhere in 3 cases. So, it will be this plus k by b whole square plus L by C whole square equal to 1. Okay. So, I can write that DHKL equal to, so 1 by this and square root of that one. So, it will be 1 by h by a whole square plus k by b whole square plus L by C whole square right to the power half, right. So, one can write this just as a minus half, just taking up. So, this is the expression for the interplanar distance of HKL plane. So, if it is cubic crystal, so A equal to B equal to C, right. So, A square, so all will be A, so A square will count. So, it will, so the square root is there. So, basically 1 by A. So, for cubic he will get, basically A by so A square plus K square plus L square, right, A by this. Now, for 1 0 0 plane, so 1 0 0, so it is 1. So, it will be for D 1 0 0 plane, this interplanar distance is A. So, that when we derive these Miller indices, we have seen this 1 0 0 plane, it intersect at on A axis at distance A, right, and B and C axis is intersect at infinity. Okay. So, Just here also we verified that our expression is correct, and for 1 0 0 plane the interference distance is nothing but this lattice constant A. So, today we will stop here, and next class I will continue this direction of the crystals and other things. So, for representing the direction of the crystal we need basically Miller indices. So, in next class we will continue. Thank you very much for your attention.